Good morning, students. This is Anjali, Assistant Professor, Department of CSE, AIML, IARE, Hyderabad. Today's our topic is problem solving on sampling distribution. First one is that calculate the standard error of the mean for the following sample sizes: mu is equal to 100 and sigma is equal to 10. So describe how the standard error of the mean changes as n increases. Now here n has given in the increases format. N is equal to 4, 9, 16, 25, 36. So we have to describe the standard error of the mean. Now first one is population distribution. Generally it's a normal. So just sample mean, we can say that the normal distribution. So it's mean that it is also 100, but standard deviation is 10 divided by root of n. So here n is your sample size. N is your sample size, and here n is increasing. Standard error of the mean decreases at the rate of the n by root n. Now first case is that we have to check n is equal to 4. Now n is equal to 4, so root of n that is 2, or standard deviation we can say 10 by 2 is equal to 5. Then in this case n is equal to 9, root of 9 that is 3, so here standard deviation is equal to 10 by 3, that is 3.3. Then next one is n is equal to 16, we have to consider n is equal to 16, again root of 16 that is 4, so 10 divided by 4 is equal to 2.5. Then again n is equal to 25, root of 25 that is 5, standard deviation 10 divided by 5 that is 2. Then next one is that n is equal to 36, so root of n is equal to 6, standard deviation 10 by 6 that is 1.6. So here you can observe that your standard deviation is decreasing. Your n is increasing. N is increasing. Sample size is increasing, but standard deviation is decreasing. Now next one is that the population of mu blood levels of lead of children who live in a city is 11.93 with the standard deviation of 3. Now for sample size 9, what is the probability that the mean blood level will be between 8.93 and 14.93? They have given the range 8.93 to 14.93, then below 7.53 and above 16.43. So now again here population is normal with the mean is 11.93 and the standard deviation they have given 3. So standard error of the mean is 3 divided by root of n, and here n is value is 9. That means 3 divided by 3 it will come 1. Now we have to find out first one, probability that sample mean is between 8.93 to 14.93. First we have to normalize it. Sample mean as mean of the 11.93 and the standard deviation is 1. So z is equal to w minus 11.93 divided by 1, and we can say p of 8.93, population of 8.93, w less than 14.93. So here by solving p of minus 3, z less than 3, then again 2 into p of 0 less than z less than 3. This value is 0.4987. So after solving, you will get the 0.9974. Then next one is that to find the probability that sample mean is below 7.3. So first we will normalize it like z is equal to w minus 11.93 and P is equal to W less than 7.53. Then after that, P is equal to Z less than minus 4.4 and PZ, that means it's showing that P is equal to Z greater than 4.4. So here 0.5 minus P 0 less than Z less than 4.4 less than 0.5 minus 0.04990, that will be 0.001. Now you have to find out the probability that sample mean is above 16.43. So normalize first. Again W is minus 11.93 and our range W greater than 16.43. That means P Z greater than 1.4, and after solving 0.5 minus P 0 less than Z less than 1.5 less than 0.5 minus 0.4332. So after that we will get the 0.0668. Now next one is population mean mu. Blood levels of lead of children who live in a city is 11.93 with the standard deviation of 3. So sample size again 36. Now sample size is different. 36. What is the probability that mean blood level will be between 8.93 and 14.93, 7.53 above, below and above 16.43. Again our sample size is 36. Standard error we have to find out, that means 3 root of n, that means 3 upon root of 36 is equal to 3 by 6. You will get the 0.5. Now first we have to find out the probability that sample mean between 8.93 and 14.93. First we have to normalize it. Then Z is equal to W minus 11.93 divided by 0.5. Now you got the answer 2.2 into W minus 11.93 and P of 8.93 less than W less than 14.93 is equal to P minus 6 less than Z less than 0 less than 6. Then 2 of P 0 less than Z less than 6 greater than 2 into 0.4990, and you will get the answer 0.998. Now next one you have to find out the probability that sample mean is below the 7.93. So again we will normalize it. 2 into W minus 11.93, P of W less than 7.53. Then again P of Z less than 8 minus 8.8. That means we can say P of Z greater than 8.8. Then 0.5 minus P of 0 less than Z less than 8.8 less than 0.5 minus 0.0499, and you will get the answer 0.00n1. Then find the probability sample mean above 16.43. Again normalize, we have to normalize it. Z is equal to 2 W minus 11.93 and the P is equal to P of W greater than 16.43. Then P of Z greater than 3 and again 0.5, P of 0 less than 3 less than 3 less than 5 minus 0.487, and we will get the 0.0013. Next one, the average height of male physician employed by Veterans Affairs Medical Center is 180.18 centimeter with the standard deviation is 4.75 centimeter. Now find out the probability of obtaining a mid height of 184.93 centimeter or greater for a sample size of 5, 10 and 20. Now normal mean they have given 180.18 centimeter and the standard deviation they have given 4.75. Now you have to find out the probability that sample mean is greater than 184.93 centimeter. Now first one is that sample size is given n is equal to 5. N is equal to 5. That means the mean for the sampling distribution of the sample average is 180.18 and it has the standard error that is 4.75 root of 5, that is 2.12. Now you have to find out normalization it. P of x greater than 184.93, then P of z greater than 475 divided by 212, that is P of 224, then 0.5 minus P of 0 less than z less than 2.24, and then you will get the 0.5 and this value is like 0.4875 and you will get the answer 0.125. Now next sample size is 10. Mean of the sampling distribution of the sample average is 180.18 and standard deviation is again 1.50. So again P of x is equal to P of x greater than 184.93. Then after that P of you will get the z is equal to z greater than 1.50 and 0.5 minus P of 0 less than z less than 1.50. Then 0.5 minus 0.4332 and then 0.0668. So now sample size again 20. Mean of sampling distribution average is 180.18 and standard error is 1.06. Again P of x greater than 184.93, your value is changing. Z is equal to greater than 1.6, that's why 0.5 minus P of 0 less than z less than 1.06. So here we will get the 0.5 minus 0.3554 and you will get the answer 0.1446. Now there are some questions about the sampling distribution in comparison to parent population from which samples are selected. First, describe the difference between the distribution of the host of the observed sample values from population and the distribution of the mean calculated from sample size n. Then next one is what is the difference between population standard deviation and the standard error of the mean. And the C, when would you use the standard error of the mean and when would you use the population standard deviation. So we'll see one by one. First one is difference between distribution of the observed sample values from the population and the distribution when calculated from sample size n. So observed data have variance that is same from one observation to the next and the sample average has a different distribution with variance that is smaller by factor 1 by n. Now it has the same mean. So it has same means, that means we can say that the sample do not have any abnormal distribution. The sample mean will by central limit theorem by distribution that will be very closer to the normal than the population distribution. Now next question is saying that what difference between the population standard deviation and the standard error of the mean. So population standard deviation is, we can say, the square root of the population variance and the standard error we can say the mean standard deviation for sampling distribution of the sample average. Random samples we can say that it generally differs the standard deviation by the factor we can say 1 by root n. Next one is that when would you use the standard error of the mean. The standard error, that means we have to use for creating the standard normal or a t statistic for testing a hypothesis about the population mean. So that population mean is totally based on the random sample and it is also used to construct the confidence intervals for the means when random sample is a variable. Next question is, when would you use the population standard deviation? So the population standard deviation we can use to characterize the population distribution. So it's used when you want to make the statements about the probabilities which are totally associated with the individual outcomes, such as like a probability that a randomly selected patient will have a measurement between the values A and B. Next question is that based on sample of 6 cases, mean incubation period for the gastrointestinal disease like 26 days with the standard deviation is 2.83. So we can say is equal to n is equal to 26 and standard deviation like 2.83. The population standard deviation sigma is unknown, but mu is equal to 28 days. So assume that data are normally distributed and normalize the sample mean. So what is the probability that sample mean would fall below 24 days based on this normalized statistic T, where the actual standard deviation is unknown and the sample estimate must be used? So normalized statistic has students distribution with 5 degrees of the freedom. So normalized statistic, we can take that T is equal to x minus 28 divided by 283 root of the 6. Here x is your just sample, that is x is equal to 26, and proportion of such estimate that would fall below the 24, that is 26 greater than 24. So here 24 for x, since probability that sample mean falls below 24, that is same with a known variance of the probability. So for that we will use the t less than 24 minus 28 divided by 2.83 divided by root of 6. So here you will get the minus 4 divided by 1.1155 and answer will get minus 0.346. Now look up t with 5 degrees freedom and find that p of t less than minus 3.46 we have to find out. So p of t greater than 3.46 minus less than 1 minus 0.99. So you will get the 0.01. So since p of t greater than 3.365 into 1 minus p of t less than 3.365 is equal to 1.1 minus 0.99 is equal to, you will get the 0.01 with 5 degrees, and so we use the one-tailed probability here. So content of the bottles of alcohol are normally distributed with a mean of 300 ml and a standard deviation of 5 ml. What is the probability that the total contents of the 6-pack exceed 1776 ml? So here you have to, they are asking about the total content consisting of 6 bottles. So first the sample mean is equal to, x is equal to sample mean we will find out 1776 divided by 6. So you will get 296. Here again we have to find out p of x greater than 296. So definitely 1 minus p x greater than x bar less than or equal to 296. Then you have to solve, you have to keep the all values and you will get the answer 0.9750. Now if you have 2 fair dice, what is the probability of getting a sum of scores equal to 4 and 8? Now first determine the total number of possible combination between 2 dice. Definitely if you are throwing 2 dice, if you are rolling 2 dice, that means your probability is like a 6 by 6. That means n of s is equal to 36. So find the first determine combination that can result in the sum of 4. And when you will check one by one, you will get with the result for some combination 1 3, 3 1 and 2 2 like that. Then after that, so for that we will get the probability 3 by 36. That means we can say 1 by 1 2. Now you have to find out the combination that can result of sum of 8. That there are some again 2 6, 6 2, 3 5, 5 8, 5 3 and the 4 4. These are the combinations which are available in the n of s. So again probability for that 5 by 36. Now when a coin is tossed 8 times, what is the probability of obtaining less than 4 heads and more than 5 heads? So h is your number of heads, h b of 8, 0.5, and using appropriate table in the appendix, you can write down the answer like h p of h less than 4 is equal to, that means we can say p of h less than or equal to 3 and you will get the answer 0.3633. Then p of h less than 3 is equal to, we can say p of h is equal to 0 plus p of h is equal to 1 plus p of h is equal to 2 plus p of h is equal to 3. Here we are finding out the probability like 1 by 2 power 8, 8 by 1, 1 by 2, 1 by 2, 2 power 7. Then 8 by 2, 1 by 2 power 4, 2, 1 by 2 power 6. So after that 8 by 3, 1 by 2 power 3, 1 by 2 power 5. Now you have to solve this. You will get the answer 93, 1 by 2 to the power 8. So 93 divided by 256. So your answer is approximate 32633. Now next one is that you have to find out more than 5 heads. More than 5 heads means P of H greater than 5 is equal to 1 minus P of H less than or equal to 5. So automatically 1 minus 0.855, you will get the answer 0.1445. Or you can say another method is that more than 5 is equal to P of H is equal to 6 plus P of H is equal to 7 plus P of H is equal to 8. Now you can solve it and you will get the answer 37 by 256, that is 0.1445. A biased die is thrown 30 times and the number of sixes seen is 8. So if die is thrown a further 12 times, find the probability that 6 will occur exactly twice, expected number of sixes and the variance of the number of sixes. Now let's consider, first we will define the x as a number of axes seen in 12 throws. So x similar b 12p. Here p is equal to 8 by 30, that means 4 by 15. Now since x b 12 4 by 15. Now again you have to solve x is equal to 2, 12 by 2, 4 by 15 square and 11 by 15 power 10. Now you will get the answer 0.2211. Then E of x we have to find out. Formula is NP. N value is 12. P value is 4 by 15 and answer is 3.2. Then again we have to find out the V of x. Formula is NPQ. N is 12. P value 4 by 15 and Q value is 11 by 75. So here answer 3.47. Then random variable x is binomially distributed with mean 6 and variance 4.2. Now you have to find out find P of x less than or equal to 6. So here binomial distribution, mean NP is equal to 6 and variance is equal to NPQ is equal to 4.2. So dividing Q is equal to 4.2 divided by 6, that is 0.7, and P is equal to 1 minus Q, that is 1 minus 0.7, that will be 0.3. So here 0.3 n is equal to 6 and n value we will get 20. So x is equal to b of 20 comma 0.3. So p of x less than or equal to 6 and you will get the answer 0.6080. Now you are about to get on a plane to settle. You want to know if you should bring an umbrella. You call 3 random friends of yours who live there and ask each independently if it's raining. Each of your friends has 2 by 3 chance of telling you the truth and 1 by 3 chance of messing with you by lying. Now all 3 friends tell you that yes, it is raining. Then what is the probability that it's actually raining in Seattle? So here we can say that this question is totally related to Bayesian theory, because the last statement is showing the particular structure. So what is the probability A is given A is true, given B is true? So therefore we can say we need to know the probability of raining in London on the given date. That means let's assume that it's 25%. So here probability of raining, it's a 25%. Now probability of B, all 3 friends say that it's raining. Then probability of A given B, that means probability that it's raining given, they are telling that it is a raining. Then probability of B given A, It's showing that probability that all three friends say that it's raining given it's raining. So that means 2 by 3 whole cube is equal to 8 by 27. So first step is that you have to find out probability of B. Now probability of B, for that you have to use the formula probability of A given B is equal to probability of B given A into probability of A divided by probability of B. Now already we know that probability of B. Now if you will transfer this thing, here we will get the probability of B and here probability A given B. So probability of B is equal to 2 by 3 whole cube is into 0.25. 2 by 3 whole cube into 0.25 divided by plus 1 by 3 cube into 0.75 and you will get the answer correctly. Now step 2. You have to find out probability of A given B. Probability of A given B means 0.25 into 8 by 27 divided by 0.25 into 8 by 27 plus 0.75 plus into 1 by 27. That is probability of A given B is equal to 8 by 11. So if all three friends say that it's raining, then we can say there is an 8 by 11 chance that it's actually raining. Now there is one box has 12 black and 12 red cards. Second box has 24 black and 24 red. Now if you want to draw two cards at random from one of the two boxes, which box has the higher probability of getting the same color? Now can you tell intuitively why the second box has a higher probability? Now the box with 24 red cards and 24 black cards has higher probability of getting two cards of the same color. Now let's say first card you draw, each deck is a red S. Now this means that we can say in the deck with 12 cards, 12 reds and 12 blacks. Now there are 11 reds and 12 black. Already we have drawn one red card. So definitely you have your odds of the drawing another red cards are 11 by 11 plus 12. So we can say 11 by 23. So now in the deck of 24 cards and the 24 black, so there would be 23 reds and 24 blacks. So therefore your odds of the drawing will be like 23 divided by 23 plus 24. So 23 divided by 27. So here since we can say that 23 by 47 greater than 11 by 23 and the second deck with more cards has a higher probability of getting the same two cards. So these are the references. You can go through these things. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.